So we both Christian and I are board members of the Passive House California, which is the nonprofit organization promoting the Passive House standards in California. Christian will further introduce himself later with his house tour, but he's a LA-based architect, and I guess you can speak for yourself, Christian.
Yes, I'm an architect located here in Los Angeles, and originally from Germany, but had an interest in passive house, and yeah, built one of the first passive houses here in Los Angeles. And during the process, we met and joined the board of Passive House California.
And I always see Christian more often than my wife, at least before COVID. And I'm French. Moved to LA in 2015, and you will know more during the tour. I'm a Passive House certified consultant, and that's it. So let's talk about the Passive House standards. We've been, the architects and engineers and the construction industry have been looking, at how to improve building comfort, and we've been doing that for quite some time. And you have here a few examples, with a Chinese house from the 15th century, or some house in Norway with a vegetation roof. But actually, the first passive house is that boat, which was a polar expedition boat, where they had already triple pane windows and 1 foot of cork insulation. And then you had the high insulation, the passive solar, and all that stuff. But all that was more like a rule of thumb. And so those guys in the late 80s. Some scientists started looking at all those studies and all those experiments, and finding that adding insulation or putting more windows towards south did not necessarily mean more comforts or less energy consumption. So they started to look and see what was making building comfortable and energy efficient. And so in 1990, that is the first passive house which was built following those building science calculations and work. Since then, the Passive House standard is the leading international low energy building standards, with almost 100,000 buildings all around the world. The Passive House Institute, based in Germany, is the one who started and promoting the concept. And what's important to know is that the Passive House standard is not only for single-family houses. You have here an example of the Cornell Tech Tower in New York, which is a 26-story building, which was certified in 2015. And if you go to New York, when we're going to be able to travel again, I encourage you to take a tour. It's a great building. And you have a 45-story building which just got permitted in Vancouver like a month ago. So don't only think small, think big. One of the first results of that science research, which has been done by the Dr. Feist and the Dr. Bo, which were the two scientists who worked on who initiated the Passive House standard, is actually that energy efficient buildings means comfortable buildings. And so, and it's as simple as a coffee cup, okay? Either, you go to Starbucks and they deliver to you with your already built-in retrofit, with a sleeve not to burn yourself, or you can use a coffee thermos and keep your coffee hot for a long time and not burn yourself. The thing is, and starting with the end, is that the Passive House standards reduce the heating and cooling consumption by up to 90%, and reducing the total energy consumption by up to 75% of the total building energy consumption. Just gives you here some examples. So the passive house standard has been around for 30 years now. And in 2000, the EU, the European Community, financed a study and looking at 250 dwelling units all across Europe. And that's what actually boosted the passive house standard, is that actually they were able to see that the calculated number matched the operating numbers, which is always a big challenge in terms of building standards, is that what you design, does it match what really happens in the real world? And so in that study, it was actually less than a 5% difference between the operating numbers and the operating numbers and the calculated numbers. As I said earlier, you know, it works for any type of buildings and anywhere around the world. Here it's an office building in China. Here that's the Belgian embassy in Kinshasa, Congo, in Africa. That one is actually the first passive house hospital in Frankfurt, Germany. So it really works for any type of building in any type of climates. Today, basically, the 100,000 passive house buildings, they are in every climate zone that you can imagine around the globe. And it also works for retrofits. Okay, so that's a house in New York. That's an apartment building in Germany, an office building. Don't remember where is that one. And that one is a brownstone in New York. And now the passive house standard is making it into a lot of building codes. And one of the reasons here is that when you look at New York, you know, 50/80 CO2 emission reduction plan, you know, reducing 80% of the CO2 emission by 2050, you can see here that the building is a big part of them achieving their goal. Vancouver is actually doing the same thing, adopting the passive house standards as their construction standards in their climate change plan. Brussels was actually the first city in the world to adopt the passive house standards for all new construction, and Europe is moving all around in that direction as well. Let's talk about price, because it's also always an issue. That one, or question at least. That one is a cost study which was done by the Pennsylvania Housing Finance Agency. And where the blue dots are passive house building and the black dots are conventional buildings, and it's a price per square foot. And you can see that the passive house standard buildings actually have a cost which is equivalent and even a little bit lower than conventional buildings. And the only way to achieve that goal is to start from the beginning. The passive house standards is just not a coat of, it's not a coat of green paint that you apply to an existing design. It's something that you take in consideration from the first line of the building that you design. Very briefly, I mean, it's based on focusing on the passive elements. So of course, the orientation, the massing, the thermal mass of the building, the insulation, air tightness, the windows, the doors. And it sets a fixed performance goals. So those goals are fixed. And so basically the primary energy it's the EUI, it's basically 15 kBTU per square foot as a key EUI, energy use intensity for the building. And the air tightness, so those are the 4 passive house goals in terms of numbers. And you have an energy modeling tool, which is called PHPP, and the goal is to match those numbers. And until you don't match those numbers, you go back to your drawing board. Just to give you an idea about those numbers, which might not mean much for a lot of you, is that a passive house, 1,000 square foot passive house can be heated up with 1,000 square foot blow dryer, 1,000 watt blow dryer, just to give you an idea of what we're talking about. And the PHPP, it's a very that's a screenshot. It's a very simple but very detailed energy modeling system, because the thing is that in buildings, the devil is in the details. And for example, if you look at the Title 24 software, one of the reasons that the calculator numbers and the operating number don't match is because there are so many loopholes. And that's what we're trying to work with the CEC to fill up those loopholes. It's Excel based. It's very easy and very cheap to get. I recommend you to take a look. It's called PHPP, Passive House Planning Package. The Passive House has 3 certification levels. The first one is Classic, and since 2015, you have 2 other certification levels. The first one is Plus, which is somewhat equivalent to Net Zero, except it's based on the building footprint and not necessarily on the building square feet. And you have the premium one, which is somewhat equivalent to carbon neutral buildings. And the reason that Passive House introduced those 2 is that the world, and we need to move towards renewable energy, but it's a huge challenge, as we can see now with everything which is happening in California with the power outage and all that stuff, is that if you look at the renewable energy we need and what's being used at the building level, a small portion, or half of it, let's say, is 30% for my house to be precise, is used directly for the renewable energy that you use. But for 50% of it, you will need to go through storage, either short-term storage, which has about 80% efficiency, or long-term storage, which has a 30% efficiency. So basically, when you look at the quantity of energy that you need compared to supply energy all year round to a building, you basically need 2 to 3 times more energy. So that's one of the major issues, and so that's why energy efficiency is a major part of the renewable energy transition. As I said earlier, the Passive House standards, it's not only for new buildings, it's also, you have a methodology which is called EnerFit for existing buildings, which is actually one of our major issues that we need to solve. The Passive House is based on 5 principles. One is continuous insulation. And when I mean continuous, is roof, walls, and floor. 2 is avoiding thermal bridges, which are basically any holes in the insulation, which basically most of the building codes forget, and which can represent up to 20% of the heating and cooling loads. High efficiency windows and doors, and shading in California. Air tightness, and continuous ventilation. They are the 5 Passive House key principles. What about in California? Passive House California sponsored a study where we can see that in California, depending on the climate zone, we have a heating and cooling consumption which can be reduced from 39 to 83% compared to coal buildings. And last year, we worked with the CEC and the California Energy Codes and Standards on that study, which confirmed those numbers and the benefits of using the Passive House standard. Last, there is much more that. First, what you need to understand is that the Passive House standards focuses on energy and comfort. That's the two aspects that the Passive House standards takes care of. Of course, there are so many other ones, embodied energy, water, energy type, and all that stuff. And so the lead since January 2019 actually gives credit to the Passive House standard projects. So with doing the PHPP modeling, you automatically get credit if you do Passive House buildings, because it's important that Passive House, it's not a certification or label like LEED can be, which takes care of much more stuff. Passive House is a tool, and Passive House is a tool which helps you to achieve better LEED buildings. Last one, how to go further after this presentation. We encourage you to join Passive House California. with all the major benefits that you can see on our website. Take the Certified Passive House Designer and Consultant Training. It's a 5-day class. It's truly an amazing class. NAPHN for North American Passive House Network is the parent organization that Passive House California belongs to. And on that link, you have all the classes. Next class is September 14th to September 18th. And it's online because of COVID. So it's actually easier. And if you have any question, that's the Passive House Cal email, and we'll be happy to answer any of your questions. I think I'm almost on time.
Great, so yes, we'll definitely move on to questions now. We have one coming in. It says, can you please expand on what are the best passive house building massing strategies? And what are the easiest passive house strategies that renters can implement to their home or office?
One of the massing strategies, let me answer this, the more compact your building design is, the easier it is to achieve passive house standards. So simple forms, simple shapes work typically the best from an energy performance. And the second part of the renters, I think as a building owner, you can do a retrofit, but if you do not own the building, I think it will be difficult to implement any passive house strategies on the building because you don't own it, and that might be challenging.
One thing that I may add is for the renter, I agree with Christian. It's more difficult. So basically, send the link to Passive House California to the building owner, and hopefully we can work on convincing him. And regarding the thermal mass, which I think also, which was part of the question, is that it does not impact the building as much as we thought. You know, it was several studies were done on that. But yeah, of course, if you have a slab or if you have a solid wall, it will help to minimize the buildings, the temperature swings, even if they are very minimal in a passive house building.
Great, thank you. So another question that's coming in, you spoke about obviously focusing on the passive elements of the buildings, such as orientation, airtightness, and other elements. Which passive element is the most important to focus on, and why?
It actually depends on the buildings. That's why, you know, every building is specific, and that's why you need something like the passive house planning package in order to design it. Of course, we can speak for LA. You know, shading is a major issue in our climate. You know, it's more, which is more cooling dominant, as we can definitely see it those last few days. Shading is a major issue. And by the way, and as you will be able to see during Christian's house tour, external shading, internal shading doesn't work. Okay, so short answer, it depends on the building. For LA, shading is a major issue. I don't know, Christian, you want to add something?
Yeah, you might want to add the air tightness. You get a huge benefit for air tightness buildings. That's in comparison to also, if you look at Title 24 insulation levels, there's not a huge difference, but the air tightness brings you a lot of benefits versus a more leaky building.
Yeah, it's actually the most difficult part for us to convince
absolutely, yeah,
local people. But yeah, I mean, air tightness, it's everywhere. But in California, if you look, and after I'm going to stop sharing that book, you can download it for free on which is
I will post the link.
And you can tell that by climate, the air tightness is actually the biggest gain that you get from adopting the passive house standards overall in all the California regions.
Great, so I think we have time for one more question. Can you please discuss a little about how to go about renovating an existing home?
Christian, since you're on mute, I'm going to start. You can kick in after. The NRFIT process, which I was speaking about briefly during the presentation, it's a step-by-step presentation. It's a step-by-step renovation. And the goal is actually to look at the existing building and to see how you can improve it. And the goal is to do the energy modeling of each one of the steps that you need to do, and showing you what will be the final result. And you can tweak it and adjust it in order to see what it is. The goal is to give you actually a roadmap for your renovation, and it may take, you know, 2, 5, 10 years. But when you do something, you know that you're doing the right things. Because today, when people change windows, they change the windows that the best window sales guy is offering them. Is it the right windows for the project? They don't know. And so the goal is to define, what's really important is to define that roadmap, and then to do the work according to that roadmap, which will guarantee you the final result.
And the nice aspect of it can be implemented over a long-term time period. So you don't need to do everything at once, because it's for a lot of homeowners a challenge. But if your roof needs to be replaced anyway, it's a good time to replace it with the end main goal in time. And then maybe over a period of 15 or 20 years, you reach the final goal of a high performance building.
And I recommend every one of you to look Beate Kierms. She's a passive house consultant as well as a real estate agent. She's actually doing a step-by-step renovation of a 1940 something ranch house in Rolling Hill Estate. And I think there are a few videos, and she did a few posts about her project. And I think it's really interesting to look at and what can be done.
Great, thank you. So that concludes our Q&A session for this part. I'll hand it back over to you speakers to introduce the first video.
Okay. So I guess the first video is mine, and sorry for the quality. I hope it's you like it. It's my first experience. You know, that's what COVID make us do. You know, go out of the regular path, and I will be looking forward to your questions at the end of it.
Hello, and welcome to the Perlita Passive House. My name is Xavier Gaucher. I'm the owner builder and the passive house consultant for this project. I took the passive house class back in France in 2014. And I must say that after taking the training, it did not make sense for me to build any other way. It allows to reduce energy consumption by up to 75% and increase comfort and indoor air quality drastically, while reducing building CO2 emissions. Buildings represent 39% of the total CO2 emissions, and they are a major opportunity to fight climate change, which we need to do now. So when we moved to Los Angeles in 2015, it was the only thing I had in mind. I wanted to build a passive house. And so we found this house, which, as you can tell, could benefit some improvements. It was 1,100 square feet, one-story house. So to minimize the impact and budget, we decided to keep the existing footprint. So we kept the foundations and the outside walls and added one story. So now downstairs we have an open living space with a kitchen, a dining room, a living room, an office/guest room, and a bathroom. Upstairs, we have a den, a laundry room, and 2 bedrooms with in-suite bathrooms. and it is 2,100 square feet. Because of the very narrow driveway, we could not add external insulation, which would have been the best way to avoid thermal bridges. So therefore, we did a double wall to have the extra layer of insulation required by your passive house energy modeling. So we have a layer of R15 insulation and a layer of R13 insulation for the walls. For the floor, we have R21 insulation between the floor joints. And for the roof, we have R38 insulations between the roof rafters. And we use standard fiberglass batt insulation. Our biggest challenge was the airtightness, which is one of the important principles of the passive house standard. So for the floor, we taped the OSB sheets, and for the walls and the roof, we used an airtight membrane, which was supplied by the insulation company. This product made it really hard to meet the airtightness numbers, but we did it after a lot of work, a lot of extra work. So my first advice is stick with products which have been used by experienced passive house crews. Don't try to experiment with unproven solutions, especially on your first passive house project. Same thing with the tape. We switched during construction from the white tape that you see on the picture to the green tape for the same reason. Every connection, every window frame, every penetration need to be sealed. So this is actually why we installed the electrical panel inside the building envelope to minimize the number of penetration. So here is one of the few penetration that we kept for the kitchen island, and that's how it's supposed to be done. Here is our airtight pet door, which we actually had an easier time to find than our airtight high efficiency double pane windows and doors. And here is our sliding glass door, which has a lift and slide system, which shields it when it is closed. Airtightness, which is one of the biggest improvements that your construction code needs to make, is quite simple if it is designed properly with proper construction details, easy to achieve on site. So it's more a design issue than a construction issue. That's also what we learned. You control your airtightness level using a blower door, which you can borrow for free from Southern California Edison. And so you do it first during construction when you can access your airtight layers, and then at the end for the construction certification. But at that stage, if you don't meet the numbers, it is too late because you cannot fix the products. Constant ventilation is also one of the passive house principles. And because it is the only solution to ensure proper indoor air quality. So on our end, unlike in most passive house, because we are in a mine climate, we were able not to use a heat recovery ventilation system. So what we have is that we have a MERV 13 filter and the fan running 24/7, supplying fresh air in the return plenum of the HVAC unit. And we have a second fan extracting air 24/7 as well from the kitchen, the bathroom, and the laundry room, keeping a balanced ventilation system. The entire house is all electric. So here you can see the condensing unit for our heat pump system, which is installed under the back patio. And this is the heat pump water heater, which is installed in the basement, which was already existing in the previous house. That's our heat pump dryer, which only requires a 220 plug and no venting. And this is our induction cooktop. We cook a lot, and we have been using induction for over 15 years, and we won't switch back to anything else. And it works well with all my wife's grandmother cast iron pans. We have 16 solar panels. The house is able to reach net zero with 12 panels. And so the 4 extra panels supply the power for the electric car that we use for all our local commute. We also have a 13.5 kilowatt-hour storage battery, which allows us to be off-grid 2/3 of the time, which is actually great during power outage. But it also made me realize how challenging is the all renewable energy transition we need to make, and how energy efficiency is a key aspect of it. I would like to end the tour with this graph, which I presented last year at the Net Zero Conference. It represents the EUI, so the energy use intensity, which is the energy required from a building per square foot to operate. And according to different building standards for whole house, and the number of solar panels which will be required to meet net zero. And what you can see is that today, a code construction can require about 2 times more solar panels than a passive house construction, which actually would pay for a big part of the $22,000 extra that a passive house construction required. Thank you for listening, and I will be looking forward to your questions. Thank you.
Okay, so we have a short time for a Q&A session. Just a reminder for participants to type questions in the Whova chat or the Zoom chat. One question that I had was, why was it so difficult to achieve air tightness on this specific project?
First of all, it was my first project, and it was the first project for the crew as well. It was the first project for the architect. So as I said, the first thing was the design part, and I'm talking about all the details. What's important is when we have, and when you take the class, the passive house class, they teach you that how you follow the red line, and the challenging parts are the connections between the floor and the wall, between the first floor and the wall and the ceiling and all that stuff. And so first of all, we did not spend enough time, and we did not look at all the details that the construction was generating. So that's one thing. The second part, as I mentioned it in the video, is that the material that we used that was a big mistake, and that was the biggest mistake, is using the wrong solution. So that's the 2 major parts. After, and you will see on Christian's project, I believe that especially for people who are not experimented passive house construction crew, the solution that he used is easier to implement and guarantees you more results. But the main 2 parts are the design and the material that we use, which were because it's not that big of a deal. It's just that it's something that you need to get familiar with, and on the other projects and the one you do after, it gets way easier.
And you have to mention the design requirement of 0.6 air exchanges per hour is very low in comparison to current standard construction or existing buildings.
But, and what I will add as well is the fact that actually working on the airtightness of the building allows you to work on the building durability and the quality of construction, because it allows you, it requires a level of quality control that you don't normally have in most buildings, let's say all buildings, and it benefits the entire construction.
Great, thank you. I think we have time for one more question. How did you find the right contractor to participate in your project?
I met with a lot of people, and basically I worked with the people who are the most motivated and the more interested about doing so. Because if I met a lot of people who did not really care, you know, and that would not have worked. So I think the first thing is that, yeah, working with people who do good work in general, you know, and in terms of detail and stuff like that, and people who are motivated and want to learn. And what I found really interesting was the fact that, let's say 2/3 of the people, maybe more, were actually, and I'm talking about the guys on the job site. A lot of them were quite interested. And the rule that I had on the job site was that no one would touch a tool. And whoever it was, the electrician, the plumber, or whatever, explaining to them what we were trying to achieve and what was important in the airtightness. And a lot of them were actually very interested to participate and to learn how to build better. And what I loved is the fact that I did not learn how the plumber to do his job. I learned, or an electrician or whatsoever. I explained to him how his job could contribute to a better building. And that was actually one of the parts which was the most interesting of the project.
Thank you. So that concludes our second Q&A session. I'll hand it back to you to introduce the second video.
Yes, the second video is a virtual tour of our passive house here in Culver City. It's a new construction building, and I think you can start the video. Welcome to Passive House, Los Angeles. I grew up in Berlin and studied architecture in Germany, where I was early on exposed to the Passive House construction standard. In 2010, with Parallel Architects, we had our first Passive House approved in Los Angeles. It's a small community center, which unfortunately became a victim of a great financial recession. Since that time, I always have tried to educate clients about the advantages and the comfort to build Passive House standard. But none of my clients wanted to be a guinea pig and wanted to be the first one here in LA to build a Passive House. When my wife and I were looking to purchase a property, for us it was always clear that we wanted to share the property and, of course, the mortgage. In 2013, we bought a 6,000 square feet property with a small 1,000 square feet typical building in the front portion of the lot. When it was time to plan for the new second house in the rear of the property, it was clear it has to be built to Passive House standard. This time I had to convince only my wife, and the argument of comfort and low utility bills did the trick very quickly. At the same time, it was important for me to create a showcase or a case study that I can test drive the potential clients and bring them into, show them how well a Passive House building is performing. Since the opening and during construction, we had already hundreds of people in the building. Passive House LA is 1,750 square feet large. It has 4 bedrooms and 3 baths. We have to say that the bedroom on the first floor is currently used as a home office, and the bathroom on the first floor is fully wheelchair accessible should that be needed at any time in the future. On the first floor, we have the kitchen, open dining room, and large living room with large windows covered by exterior shades which are fully automated in order to block the sun and keep the Southern California heat outside the building. On the second floor, you see the outdoor deck, which is at the same time the cover for the required carport. We have a gallery for the large book collection, and then the master suite with the master bathroom attached. The bathroom on the second floor is very compact. In order to save more floor space, we combined shower and bathtub, so you need to walk through the shower in order to reach the bathtub. The building is an all-electric home, so we do not have any gas for cooking. We are using an induction cooktop, and also for the laundry, for the dryer, we are using a condensation dryer. Casa Fasalay is a wood frame building. The exterior walls are framed by 2x6 members, and the building is sitting on a snap-on grade with an R10 foam insulation below. The cavities in the walls are filled with low-end insulation, and on the exterior we have a continuous rock wool insulation with a rain screen and metal facade finishing the building. On the roof we have a TPO roof enclosing the building. In terms of building systems, we're using a heat pump water heater with recirculation pump. Each bathroom has a motion sensor installed, and that triggers the recirculation pump, and this way we have immediately hot water at the tap. For the heating and cooling in the building, we are using a one mini split system for the entire house. The house is 1,750 square feet, and we actually had an open house, which was quite interesting, and we had the representative from the air conditioning company out here asking, how do I like the system? I had to tell him, I don't really know. I rarely use it because it's most of the time not needed, and the ventilation system, the heat recovery ventilation does pretty well here in order to provide sufficient airflow and comfort in the building. For the continuous ventilation, we have a Comfort Air 550 in the building with a MERV 13 filter. During the construction and also in the end at the final door blower test, those are always nerve-wracking moments in the process of a passive house. Turned out we came in at 0.48. For us, it was very important to have a lot of daylight in the building, especially in Southern California. It is critical that you have to have large windows if you want to have a building which is succeeding in the local market here. That meant large windows, lots of daylight into the building, that we needed to come up with an exterior shading strategy. Most people do not have exterior shading here, which is very surprising to me, because if the heat is in the building, it's delayed, and we typically solve bigger air conditioning in the past. But shading belongs on the outside, and we choose an automated Venetian blind shading system, which fully operates automatically. We have a roof sensor which tracks the sun and is adjusting the blinds as needed. The great part about that one is we are still getting daylight into the building, and At the same time, it still can look outside the building. You will see also in the videos, we don't have any interior curtains. We're using the exterior blinds also as our privacy screen, which works very well. In terms of on-site renewable energy production, we have 16 solar panels on the flat roof. We are net zero with only 10 solar panels, and we also have a battery backup system. So the solar panels are feeding the battery backup system, and the disconnect is located behind the battery. So even during a power outage, the solar panels keep feeding the battery, and the house can draw via a critical load panel the generated power. So we have an independence should be there power outage for a longer time. Thank you for joining us on this virtual tour of Passive House Los Angeles. Please feel free to visit us also online at www.passivehouseLA.com.
Great, so we have about 10 minutes for questions. We're going to take specific questions to the previous video that you just watched first, and then we'll open up to a more general discussion. The first question for you is, what is the sizing of the mini split system?
We used actually the smallest mini split system which was available on the market. They have now a little smaller one, but it was the smallest one because we just don't need it. We're in a moderate climate here. And as I said in the video, we rarely use it. And it's the smallest one that MGBCE had available, but they just recently developed specifically for the demand of passive house buildings, additional, even smaller units.
Thank you. Next question, how do the exterior shades handle Santa Ana wind conditions? Are they secured at the sides, for example?
These shades, they come with two systems. One is a cable system, and that's where we have windows which are adjoining each other. And in a regular window, they have rails on the outside. And so far, in the entire time we're now in the building or have them installed since 1.5 or 2 years, only once actually the weather sensor on the roof detected too much wind. I don't know at what mileage per hour it actually retracts them. There was one night where the wind was too strong, and then they automatically retract and go into their closed position so that there is no damage to them. I think I have to look it up what exactly the numbers were, the wind speed, but it happens very rarely, and they're self-protecting in that direction. And also the sensor automatically closes the side which is needed and is adjusting it. Something which is very nice on it, you will never see the shadow or the hard sunlight on the floor. It's always blocked out because they're tilting every time in the direction is needed to provide the best sun protection, and it has a huge savings aspect in terms of heat gain through the windows.
Thank you. And in reference to the previous question about the mini split system, the participant wants to know the actual BTU if possible.
I think it was 9,000. I think the smallest one used to be 9,000. Now they have a 6,000. But you can contact me and I can provide that information. I can put it in the chat room shortly.
Sure. And in the meantime, what brand of exterior shades were used?
This is actually a German company who's around since many, many years. And in Germany, actually every building, or in Europe, most of the buildings, almost every building has exterior sun shades, even so there's almost no sun in comparison to California. And that brand was, ended up with Varema. And there's a local representative here in California who is working with them together. And they are coming from Germany. And it's a well-working system. We have it installed since 2 years, had no problems. And the nice thing is about the shading system, it works automatically. So you cannot forget about it, that you have to close the blinds or open the blinds, and then the building is warm or cool. It works fully automatically. And as I said, I don't like to have curtains in the buildings because I had to wash them at my grandmother's house always, and I hated hanging them up all the time. And so it works well as a privacy. And that's also why we use the exterior aluminum blinds versus the textile shades, which are available too.
Thank you. Another question that just came in, how many extra kilowatt hours does the PV system produce annually?
We had in the first year of operation, we had an excess of 2,500 kilowatt hours, which went straight back to the grid. And the reason why we had it oversized a little bit, because we were planning for an electric vehicle. At the time, we didn't have an electric vehicle, so that's for a future electric car. And if I do the conversion, that gives me almost 9,000 to 10,000 miles driving in a Tesla 3. So that's why we had the extra panels on the roof. But we would be net zero with just 10 panels. And that's pretty good if you figure in that's an all-electric house. So we don't have any gas in the house, so everything is electric-based. Because for me, it didn't make sense to put an explosive gas into a house in earthquake country. And so everything is fully electrically based, and we still have a significant overproduction with a very small number of panels.
Great, thank you. Yeah, just a reminder to type your questions in Whova or the Zoom chat. We can go ahead and open it up to more general questions regarding Passive House. One question I had is that you spoke about widespread implementation of the Passive House standards across Europe. Do you think that the US is behind in this standard, and how can we achieve the bold implementation seen across Europe?
Actually, the US or North America is not so far behind, especially for specific locations. I mentioned in the first introduction, New York, Vancouver, but Pennsylvania. Pennsylvania, there's a lot of low-income passive housing. New York is having a lot of passive house projects, and Vancouver as well. So the question is, how do we meet, do we implement the passive house standards more broadly? First of all, is that if you have solutions, I would love to hear them, because I've been working on that for almost 4 years now, and it's definitely not working fast enough. I think in California, people feel that because of Title 24, which is one of the most restrictive building codes in the US, they don't need to go further. But as the study showed it, and how my operation members confirmed it, we gained 64% in terms of heating and cooling consumption compared to Title 24. And so we need more events like that, and we need people to take the class, and we need more buildings. And we need larger buildings. That's why we did the multifamily study with the California Energy Commission, is that we need larger buildings. That's the key aspect of it, and we need incentives from utility companies and from jurisdictions to give a higher floor to occupancy ratio to high efficiency buildings and stuff like that. And I'm talking about when I'm talking about the numbers need to match the operating numbers, because a lot of times you have people say, okay, that's the way the building is going to operate, and you have that big gap between the operating conditions and the calculated numbers. And so we need actually more buildings is the key. Do you think I answered the question?
Yes, thank you. Perfect. This question, I think, is in regards to the previous video, so we're going backwards a little bit. But how much of these materials are spec'd out prior to construction?
All of it.
Or everything. You have to plan it. You have to plan from the beginning. Basically, when you start designing a passive house building, you want to make sure that you have the passive house consultant or the design or the architect who is a passive house designer involved in it, because a lot of decisions which you make in the schematic design phase have a ripple effect through the entire project. And in order to have also the PHPP, this Excel file for the performance calculation work, you basically have to put everything in there. Every material, every performance value, every U value, everything goes into that calculation. And yes, I mean, you can make some substitutes or some modification in the process, because sometimes happens projects are discontinued or something along that line. But yes, you need to plan everything up front. As an afterthought, passive house works, but it makes it difficult, it makes it frustrating, and it makes it more expensive. So if you have passive house implemented at the first step, it makes it so much easier and so much easier to achieve in that direction, because there's an efficiency in that process.
I like to say, that every decision that you make on the job site is a wrong decision.
True.
All right, thank you. I think that covers all the questions that are coming in. So I'll hand it back to you guys for any concluding remarks.
Christian, I started. Go ahead.
That's fine. Yeah. Thank you very much for attending, and we're glad to see such a huge interest in passive house buildings. Unfortunately, we couldn't have the tour in person, and hopefully when COVID is better in control, we will be able to have open house tours again. Typically, we have participated in passive house international open house tours, which we had twice a year, where we had hundreds of people in the houses, so you can really test and feel a building and experience it, how it's performing. And should you have any questions, please feel free to contact Xavier or me, or contact directly Passive House California, the nonprofit organization who will be able to assist you in projects, and who will be a good resource for you to find out more information if we sparked your interest in passive houses.
The only thing, if I may, that I would like to add is that the passive house community in California, in the US, and worldwide is a fascinating community. I would never have been able to do my project without that community. I know it's always scary to do your first project. First of all, you cannot do work and code buildings if you try to achieve passive house, so go for it. And that there is a huge community which can share. There is discussions going on all the time. You can ask questions, and it's don't be scared. Jump, and it will be people to help you. We need that to happen now.
Great, thank you. I think that covers it.
Thank you very much.
Thanks for attending. Thank you.
Thank you. Take care. Enjoy your weekend.